Hello, here's page 8 of the experiments, and we're starting with number 4. A sports scientist is testing the relationship between speed of muscle movement and the force produced. In 10 tests, the following data is collected. This really sounds like a IA, doesn't it? Explain why it might not be appropriate to use Pearson's moment correlation coefficient in this case. So remember that Pearson's is looking usually to see if you can do linear regression, and this is a pattern, and it is a monotonic decreasing pattern from the looks of it, but it is not a line. So that is why we're probably not going to use linear regression in Pearson's. So in this case, maybe we can use the fact that it looks like it's monotonic decreasing, or it's like steadily decreasing, and maybe we could use Spearman's. Okay, so in this particular case, let me order the x values here. So let's see. So I'll write. I'm looking at these numbers here, and it looks like the smallest value looks like it's either H or J. I'm going to have to look at the exact data to be sure. So H is 2.67, and oh, don't forget about this one. Look at L. Oh my gosh, L is very low. Okay, that's Y value though. Okay, so so if I'm ordering the x values, it looks like they're already in the right order, aren't they? So I got 0.25, 0.51, 60, 0.69, 1.09. Oh, very nice of them. They already put everything pretty much in the right order, except for K. K's over here. So K is very much to the left. So that is our smallest value, isn't it? L is also looks like it's maybe inverted with I and J. So so looks like L goes between I and J, doesn't it? So slightly out of order. Okay, so let's do this. We're going to put negative 0.29 is the smallest, and then we're going to start numbering in order. So D is 5, for example, and then we'll put 6, 7, 8, 9, and then 2.93 would be 10, and then 3.09 is the next one, so we make this one 11, this one 12, and this one, we already numbered this one number 1. Okay, so we have 12 data points, and we've numbered them all the left x values, we've already numbered them with red rankings. Now we're going to do the same thing with the y values. So the smallest y value is the L. So I'm gonna say that one's blue 1. And then the next smallest one is either H or J. H is 10.2. J is 10.3. So actually this is the second one, and this is the third one. And then after 10.3, there is a 10.8, which would be 4. I looks like a bit. And then G would be the next one. That would be 5. And then F or E would be the next one. Looks like they're tied. So they're tied for 6th and 7th place. So we'll put 6.5 for each of those. 6.5. And then, so we've used up 6th place and 7th place. 8th place would be D. 9th place would be C. And 10th and 11th. Oh, I'm sorry. Look at B and K. B and K are very close. So B, 25.1. K, 25.07. So actually, K is first, right? K would be 10. And then, B would be 11, because it's 25.1 is a little bit bigger than 25.07. And then last of all, the A point, 30.4, that's the biggest value, so I put 12, okay? All right. Okay, so now I'm going to put in the data, and so I'm going to put in, it in the order A, B, C, D, E, so just to make it easier. And so I'll start with 2. Okay, but I am just going to do this offline so it's not really boring for you. Okay, I'll come back with everything. Okay, and so I just input all the data in the order A, B, C, D, and then I'm going to do stat.calc.linreg. And we'll check out the R value. So the R value is negative 0.942. So R value, R subscript S actually, is negative 0.942, three significant figures. Interpret the value of R of S. Okay, so it's negative and strong because it's very close to 1, right? Between 0.75 and 1 is strong. And comment on its validity. Okay, so if you look at this region, especially around here, the validity, we could say that the force values sometimes are really close together. So any little change in the force values, and it could really affect the R value. Okay, so you could write something about that. In fact, like these also are very close. So like the force values are very close, and so like any small change will affect the R subscript S, right? Okay, let's go to the next one. A class took a math test marked out of 80 and an English test marked out of 100, and the results are given in the following table. Calculate the PMCC for this data and comment on the result. Using graph software to plot these points on a scatter diagram, comment on the result from A. Calculate the Spearman's rank correlation coefficient for this data and comment on your result. State which is the more valid measure of correlation and give a reason. Okay, so first we're going to put this data into L1 and L2 and do linear regression on these values. And the other thing we're going to do is we're going to do it on the rank. So why don't we look at the rank first and try to put these in the right rank order. And looks to me like the X, from the X point of view, everything is already in order. So that's very convenient. So oh, look at that. There's a tie. There's a tie for 10th and 11th place. So we are going to number, oh, look at that. And there's also a tie for 8th and 9th place. So for 8th and 9th place, we're going to put 8.5 as the two rankings there. And then when we have a tie between 10th and 11th place, we're going to mark both of those 10.5. Okay? And then we're going to do the same thing on the bottom, except now we're going to do it in blue for Y, and we're going to number these in order of rank also. So the next biggest number is 44, but there's two 44s, so there's a tie between second and third place, so we put 2.5. And then 4, we would put that for 47, we would put 5 for 49, 6 for 52, 7 for 54, 8 for 59, 9 for 69, 10 for 78, and 11 for 89. So first we're just going to do the regular data using Pearson's linear regression, because apparently this might be linear, but we need to take a look at the data first. So we'll start there. We'll put 15, comma 44 and go from there, and I'll do that offline so I don't bore you. Just put the maths and English black numbers into L1 and L2, and now I'm going to do stat.calc.linreg. Check out the R value, which is 0.6699, which is 0.670. Okay, so our value is 0.670, and if I comment on it, I would say it's positive and moderate because it's between 0.5 and 0.75, so not strong. So is it linear? Kind of linear, okay? Then it says to plot it. So I'm going to do that here just to like show you how you do that. You go to second stat plot. I turn on the first plot 1, and then I say, yeah, it's scatter, which is that one right there. And then I say list 1 and list 2, and I say that I want to print it little dots there with little holes in it, and that's fine. And then I'm just going to go back here and I'm going to turn off the second plot because I had that on from before. Okay, and then I'm going to graph. And it's going to print, it's like way off the screen. So what I'm going to do is I'm going to do zoom stat, which is one of the zoom options, and then it'll make sure that my dots are on the screen. There it is. So you get, oh, so do you see it's not really linear, okay? It's kind of linear, okay? There's a general upward trend, but not really linear, right? Okay, so we got this picture, which kind of makes it look like the data kind of goes up like that, right? Now let's try to do, we'll put in the red and the blue data into stat edit, and then we'll find out the Spearman's correlation coefficient, which I'll do offline so that I don't bore you again. I put the red data in L1 and I put the blue data in L2, and now I'm going to do stat MAIlinreg on this data and see what my R is here. So it's 0.883. RS equals 0.883. So that is positive and strong, right? Positive, strong. So state which is the more valid measure of correlation, give a reason. Well, I would say that R of S is bigger than R, and it's significantly bigger, right? One is strong. One is strong, and the other is moderate, right? So because of that difference, I would say that the rank relationship has more correlation than the linear relationship, and we could see from the graph of the linear or the graph of the original black number data that it's not really linear. So we should probably use Spearman's in this case, right? By the fact that it's not really linear, okay? But it is, the rank correlation is good. Okay, let's do number 7. Okay, so let's look at this data set. And for this data, calculate the PMCC with the outlier J and without the outlier J. Okay, so in this case, they're saying calculate the linear regression of these points and not this point, and then do it with that point. So we're just going to put in these numbers first into stat edit, and I'll do that offline so I don't bore you. And then afterwards, I'm going to put J in too. Okay, but first I'll do it without J. Or no, first I'm going to do it with J, then I'm going to do it without J. So I just put in all the data, including the last point J, 7.6, 4.98, and then we're going to do stat MAIlinreg to see what the R value is. And our R value is 0.874. So it's 874 with J. And then without J, all we need to do is remove the last point here. I'm just going to remove the X point and the Y point for J, which is this last one. So clear, clear, or maybe delete. Sorry, it's delete, not clear. Okay, so we removed J, and then we're going to do stat MAIlinreg again. And it's 0.0776. That is pretty bizarre, isn't it? Look at the way, just by removing J, we've like totally changed the R value. The R value was strong, right? Before it was positive strong, 0.876. That's between 0.75 and 1, so it's positive strong. And once we remove J, it becomes positive weak. Okay, so that's a huge difference. All right, now it wants us to do Spearman's rank correlation coefficient with and without J and to comment on the results. So the first thing we're going to do is we need to rank the left X values here. So we're going to rank these. Hopefully they'll be kind of in order. Let's see. So let's see. 1, yeah. 2, 3. Oh, C and D are not in order. So I'm going to reverse this. D is 1.46. C is 1.78. So that would be 4. 5 would be G. 6, 7 would be 2.46 and 2.48. I would be 2.98. 9 would be 3.02. And 10 would be 7.46. And so let's do the blue values. So the smallest value looks like it would be 0.62. Oh, but look, there's a tie with this one. So we'll put 1.5 here and 1.5 here because there's a tie between 0.62 between D and I. The next smallest values look like A and E, and it looks like E is the smaller value. So the next value will be 3 because we used first place and second place for D and I. And then the fourth place would be A, right? The next smallest value looks like it would be C. I'm cheating by using, the graph. The next smallest value looks like it would be H. H would be 6, 1.42. And then B would be 1.56. That would be next. And then F. And then G. And then last of all would be the outlier, J. And so now we're going to do the same thing. We're going to include the outlier and then without the outlier, and we're going to see the difference between the two. And I am going to input this into StatEdit, and I'll do that offline so I don't bore you. Okay, I just input the red and the blue numbers, and now I'm just going to do StatCalc.MAIlinreg to see what the R value is. Okay, you can see that like when we do Spearman's, we're not interested in the line equation. We're only interested in the R value. So the R value, in the case, the Spearman's value for with J would be 0.304, which would be positive, very weak, right? Very weak. I'm sorry. 0.0776 is also very weak, right? Because it's between 0 and 0.25. Oh, I'm sorry. There's a double screw up there. 0.304 is weak, not very weak, because it's between 0.25 and 0.5, right? Now let's do it without the outlier J. To do that, all we need to do is go down and erase the last rank, which was 10. Yeah, so we just delete that one. And we delete that one, and then we repeat StatCalc.MAIlinreg, which is option 4, and then we run again, and our R value is, wow, look at that. So now our R value is 0.0418, which is very small. Now it's positive, very weak. So if you look at the impact of the outlier for linear regression, you can see that the outlier really makes a huge change in the Pearson's value, right? It goes from very weak to strong, right? If you look at the Spearman's, the impact of the outlier changes also quite a bit, but this time it goes from very weak to just weak. So it doesn't quite change as much. So the outlier seems to impact, the outlier impacts Pearson's more strongly than it impacts Spearman's. Okay, although it does have a strong impact on Spearman's also, it goes from very weak to weak. The impact on Pearson's is very high, right? Very weak to strong, okay? So that's our comment for that.